Welcome to our flipped classroom, where math knowledge makes things easier. Our objective today is that today I will be able to compare the value of writing a variable expression in a different form. This is part of the 7th grade Common Core Curriculum content standards involving expressions and equations, specifically 7.EE. As we learned previously, when factoring expressions, there are different ways to represent the same expression. Take, for example, this rectangle, whose product, the area, is 300 plus 50h. We could have two different factors that could be multiplied together, the length times the width, that could give us the area of 300 plus 50h. If we factored out, say, a 10, 10 is common to 300 and to 50h. If we factored out a 10, 10 times 30 would give us 300, and 10 times 5h would give us 50h. So what we could say is these two expressions really represent the exact same thing, the area of this rectangle, which is 300 plus 50h. However, we didn't have to necessarily factor out a 10. There are other terms, other factors for 300 plus 50h. Say, for example, that we factored out a 5. 5 is a common factor for 300 and 50h. 5 times 60 would give us 300, and 5 times 10h would give us 50h. So all three of these expressions really represent the same thing. 10 times 30 is 300, 10 times 5h is 50h, 5 times 60 is 300, 5 times 10h is 50h. Let's look at another example. A medicine requires that you take 20 drops of medicine along with an additional 2 drops for every pound that you weigh over 150 pounds. The question asks us to write an expression to represent the amount of medicine one should take based on your weight, W. So W is our significant variable that represents a person's weight, and that depends on the person. We could put in different numbers for different people for W, which represents their weight. Let's look at the problem again, though. We could simply say that you're taking 20 drops of medicine along with, so you're adding 2 drops for every pound that a person weighs over 150. So it's that difference between their weight and 150, or 150 and their weight if it's over 150. 2 drops is only if it's more than 150. So there's our algebraic expression. 20 drops regardless, plus 2 drops for the person's weight over 150 pounds. So you subtract the 150 pounds from their weight, multiply that by 2. How else can we represent that algebraic expression? Well, what have we done here? It's really the exact same expression. We've just used the distributive property to distribute that 2, to multiply that 2 by every term within this parentheses. It's 2 times W minus 150. The product of 2 times W minus 150, 2 times W is 2W, and 2 times negative 150 is negative 300. So this expression is really the same as this expression. It's representing the exact same thing. Is there a third way we could represent this expression? Well, here we wrote 2W minus 280. Where does the 280 come from? We just combined like terms. We have 2W here. There's our 2W. We have 20 minus 300. Positive 20 minus 300 will give us negative 280. These are 3 different ways of representing the exact same thing. What about this expression? For this problem, the goal for the diet is that everyone should lose 1/5 of their body weight. write an expression for their new weight. There's several different ways we could write this expression. We could write that ideally the person should have their old weight and they should they should lose 1/5 of their weight. So we have their weight and we're subtracting 1/5 of that weight. Remember, every fraction is also a division problem. So we could really say this another way. This is their weight, and you're subtracting 1x divided by 5. 1/5 of x is 1x divided by 5, dividing into 5 parts. There are several ways to write this expression. If you haven't figured this one out, we could just say that x minus 1/5 x is going to leave 4/5 of the x, 4/5 of the weight. If you have your weight and you subtract 1/5 of your weight 1x, representing 5/5, and you're subtracting 1/5, you'll be left with 4/5. Another way of writing the exact same expression. In class, we talked about converting percents to fractions and fractions to decimals. So we could simply write 4/5 x as a decimal. 4/5 or 8/10 could be written as a decimal. 0.8x, 8/10 of x. Each of these expressions represents the exact same thing. Sometimes writing the expression in one way over another makes the problem easier to solve, but all of these would be correct in expressing this particular problem. So today, hopefully, you were able to compare the value of writing a variable expression in a different form. Be prepared to demonstrate your learning in class, and I'll see you there. Looking forward.